let's look at the third D2 column from CSS. So what's going on here? We have n coins, each one has a different value, and we want to figure out the number of ways that we can make a given sum. So for example, there's 8 ways to make 9 out of 2, 3, and 5. And notice here that 225 and 252 count differently, even though they have, it's like 2 2s and a 5. And similarly, these last 4 are the same, except, the 3 is first, 3 second, 3 third, 3 fourth. So, yeah, we're counting all those separately. So we give an n, the number of coins, the target number, and the values of each coin. And we print out the number of ways modulo 10 to the 9 plus 7, because there might be a lot of ways, especially with this switching back and forth. So let's do it. We'll do this one bottom up, right, with the array instead of a recursive function. So dp n is so basically, you just recurse over the first coin, right? The number of ways to make n. Well, if you put in 2, then one way to make n is to put in 2, and then n minus 2. And then any way to make n minus 2, right? And so the same thing for all the columns. How many ways do they make 0? There's just one. Do nothing. Let's do the base case. Y will be the number that we're trying to make. Instead, actually we need this condition. You don't want to go into negative numbers, and obviously if your coin is bigger than n, there's no way to start with that coin, right? If you're already too high. So that's the condition. Okay, so we're filling it in for one y at a time, and we have to start, go up, because for each y we're looking at some smaller ones. So if we start at 1 and go up, then we'll have filled in all the elements of the array that we need to look at by the time we get to it. So that should be it. Oh, yeah. Do the usual arithmetic, the library up there. And let's see if it works. Okay. Time limit exceeded. Oh no. They gave us a second to do 100 million operations. So probably the slow thing here is all of these modulos, right? This actually has to do with division every time. So one thing that we can notice is we're using 64-bit integers. The maximum value here is 10 to the 9. 64-bit integers go up to 10 to the 18. So how about we just do the mods once at the end. can accumulate the value without any mods. It'll get up to almost 100 times this, which definitely fits in a 64-bit integer, and then we can mod at the end, and that'll be 100 times less divisions, which will make it a bit faster. Cool. So that works. I think they set the time limit a little obnoxiously tight here. So anyway, yeah, this is bottom up. So no recursive function this time. We're just filling in the array manually. And we had to do this trick where we only mod at the end to speed it up. And that was okay because each of these values is at most 10 to the 9 plus 7, and a is at most length 100. So dy is not going to overflow. Right? We'll only go up to 100 times this. The runtime is just n times x, right? Which you can really see from these for loops, right? Here's x, here's n. And we just had to figure out this recursion, right? This is the key formula, so you just brute force over which one you're doing first. So that's all.